Hi everybody, welcome back to another video of Master Math with Ade where we'll be making math easy and fun. So today we're talking about a crucial topic which plays a significant role in both everyday life and scientific research, which is estimations and approximations. We'll be exploring concepts like the absolute error, the least unit of measurements, relative errors, and many more. So understanding these ideas are essential for everyone working with numbers, whether you measure something in the lab or managing finances. So, in engineering, approximations are essential for making things work. For example, if something isn't quite right, you might need to round up or down to make it fit. Whether you need to cut 30 meters of wood or just chop it into smaller pieces, approximations can really save the day. Similarly, in cooking, estimations and approximations are key. Have you ever found yourself wondering if that teaspoon of salt is really enough? Or maybe you don't have a cup measure handy, but you know you need something to eat in the next hour. In these situations, estimating is a lifesaver. So next time you're cooking or working on a project, remember that estimations and approximations can be your best friend in the kitchen and workspace. So, the first thing we'll look at is the least unit of measurements. So, least unit of measurements is the least placement value of a given measurement. So, like, for example, if you have a certain number and then the least value it can be changed into is the least unit of measurements. So, what I mean is when you have a number such as 15, we have 15. So, the least unit of measurements of 15 is 1. So how you find the least units of measurement depends on the decimal places. So 15 is the same as 15.0. So 15.0 only has one decimal place, which is this 0. Or simply it has no any other numbers after the decimal point. So since it only has one, which is 0, the least units of measurement will be 1. So for other numbers such as, so if we have 20.3, since this one has 3 there, not 0 but it has 3, so the least units of measurement for this one will be 0.1. That will be the least unit of measurement. And if we have 20.33, the least unit of measurement will be 0.01. So if you have noticed, here we have one decimal place, so we will have 1 also here. We have 2, so even here we have 2. So if we have 20.333, so it will be 0. So you have to say 1, 2, then the third one will be our 1. So these are the least units of measurements of these numbers. So the least unit of measurements of a number is determined by the number of decimal places that specific number has. So now, since we've talked about the least unit of measurement, let's talk about the absolute error. Before we look at the absolute error, let's look at upper limit and the lower limit. So upper limit of a certain number, so we had 15 as our first example, right? And then we said its least unit of measurement is 1. So 15 is upper limit will be the true value plus the least unit of measurements. That will be the upper limit. So 15 plus 1 will be 16. So this is the upper limit of 15. And then the least limit, the lower limit, will be 15 minus 1, which is the least unit of measurement, which will be 14. So the lower limit of 15 is 14. This actually applies to the other values where we had 0.1 as our least unit of measurement. So when we had 20.3, we said our least unit of measurement was 0.1, right? And now if they ask us to find the upper limit, upper limit will be the true value, which is 20.3, plus the least unit of measurement. So that means the upper value of 20.3 will be 20.3 plus 0.1 will be 20.4. So that is the upper limit. So for the lower limit, if it was lower limit would be minus. So 20.3 minus 0.1, it would give us 20.2 as our lower limit. So we've understood upper limits and lower limits, where you just have to determine the least unit of measurement, which is determined by the number of decimal places. Then you add it for the upper limit to the true value, and then you subtract to the true value from the true value if it's for lower limit. So absolute error, we have two ways of finding the absolute error. So the first way is when we have two measurements which are given to us, we have to subtract one from the other, and then it will give us our absolute error. So if I have a question such as maybe a table measures 4.48, let me say 48.7 centimeters. That's what a table measures. If the true measurement of this table is supposed to be 50 centimeters, and then they ask us to find the absolute error. So when we're finding absolute error, there is a specific formula, but it's not actually complicated, but this is how it goes. So absolute error, which is AE, will be equal to, we put these two lines. So these two lines are modulus bars. So modulus, so we'll say recorded value, the recorded value minus the true value. These two are values. So recorded value minus the true value. So in that question which I gave you, the recorded value was 48.7 minus the true value was 50. So when we subtract this would give us negative 1.3. So now the purpose of the modulus bars will turn this negative over here into a positive. So therefore, the absolute error is 1.3 centimeters. That is one way to find absolute error if we're given two measurements. But now, what if we're just given a single measurement, then we're told to find the absolute error? So if we're given a single measurement, maybe let's have another example. So if a piece of wood measures 6.5 centimeters long, then they ask us to find the absolute error of this measurement. So finding the absolute error of a single measurement will be absolute error will be equal to the least unit of measurements divided by 2. That is how you find the absolute error of a single measurement. So the least unit of measurement of this one, since it has one decimal place, so the least unit of measurement for 6.5 will be 0.1 as our least unit of measurement. And then therefore it will be 0.1 divided by 2. So when we have 0.1 divided by 2, this would give us 0.05. So centimeters. So that is our absolute error for 6.5, which is a single measurement.